I never. How was it?
Well, first of all, I set my alarm for 6, and then I'm like, oh, I can sleep in about 20 more minutes, like, it's fine. Then I woke up and it was 6:50 when I leave, so I got ready at 5 minutes, like 5 minutes. I've never been so impressed with myself. I was running around and I left at like 6:55.
Oh my gosh.
And I got there, and the coaches were there, and the doors were locked, like,
Is anyone there?
yeah, everyone's there, and the coaches are there, and the doors locked, and so we're all sitting out there for like 20 minutes.
You could have slept in 20 minutes.
No.
That's annoying.
And we have to go for it.
I heard you were starting to work at Crier. That's so fun.
Yeah, I saw your mom yesterday.
Oh yeah.
She always has these outfits on too.
And she's so stylish.
So stylish.
Always.
It was so funny because she had like her high boots on with her really fancy outfit, and
Oh.
she like explained to us that she didn't want to get her nice shoes wet.
That's funny.
Should you do the fry out
Do you know like that one place?
Uh-huh.
Yeah, it's like, yeah.
What are you? Oh, I was not saying.
Yeah, no. Like you like change into a robe and then like they come in and then you go in the shower. That's good job. That was really good. I like the whole beach change.
Oh, almonds was good too.
Yeah. Oh wait, I remember we got a fly down here. Anything that? Oh, why? I was good.
You know, I wasn't even here on Thursday, the first week, so.
You have to like. You have to like show I would try to do it. You already have your resume set up to use Diane.
Dan was a wait list.
Oh, I guess I'm not sure. In UNC, yeah. I don't even want to go to Michigan anymore. I think I know.
How was your 3 days?
Like a what? Like the sorority stuff? Oh yeah. But like I feel like it's fine. Actually, what happened was I saw you. I thought to go into there. I should offer her back. And I was like, that's so weird. But no. Really?
I mean, I saw that in my email, but like, but you didn't actually.
It's kind of fun.
It's kind of funny
How
because
come
I noticed it.
I don't know if it's bad.
Maybe you were meant to print it, but I just didn't like it.
Which one?
I mean, my name. They're due Thursday.
Yeah, Tuesday.
How's your separate scholarships for Arkansas?
Do not go to Arkansas.
Why would you put those in? I had so much stuff.
Wait, I can't find it.
Or like, I just saw it. Yeah.
I can't find it.
I'm like, that sounds good.
Mine.
Today's the 20th, right?
Yeah.
32 is composite.
Terrible.
Oh my god. Yeah, I really studied for but it was on a computer and I just
Wait, who's okay? Hey.
Wait, was it? I almost thought and then, yeah, the
I'm
things
just
are
not good at all of doing that.
math, so you had to keep looking back and forth in the screen, because you have to use computer and stuff, and for like reading, you can't mark on the other stuff, and for English, science, I write stuff on the
Were you here on Thursday, not last week's Thursday, the week before? The only other meeting.
I think so.
Okay, I missed that day. Could I look at the stuff y'all did? Cause I couldn't see like the notes you took on the website. Like here.
Drinking direct.
No, you're all good. And then is this just based off of the recess? Okay, then I can figure that part out.
Let's see, Oliver. 2, 3.
I'm gonna need something.
Matt, Aiden.
I'll be okay.
2, 1, 2, 1, 2, 3. All right, just in case we get the minute of silence here, if somehow you forgot to turn in 73 and 75 in the Google Classroom, you need to do that. Otherwise, it will be late if I don't have it in the next couple minutes when I start grading it. So, if you 73, 75, it's under belt work. If you were not sure, you should probably double check. All right, I'm going to go ahead and get started here. We've got a lot of little things to look at. I don't know if we'll get cut off for a minute of silence or whatever, but so you guys picked up a couple handouts today. We need to talk about the difference between distance and displacement. There's 2 FRQs on a handout that you already had, 74. We only did 1 of those so far. Then we need to look back at the first FRQ on 74 because that's going to play a big part on today's circuit. And then finally, to try to help offset some of the time that you missed, of course, you were scheduled to take this test like last Thursday or something, so of course we're having to push that back some. But some of helping you get caught up as well as I'm giving you the test review early. So the last 2 pages you picked up today, both of those make up 81. And I'm giving them to you early so that you are encouraged to start working through there. There's a few of them.
Good morning, Fable High. Today is Tuesday, January 23rd, 2024. Would you please join me in a minute of silence? Please join me and stand if you are able and join me in the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you and have a great day.
Okay, so again, part of how I try to offset and make this a little bit more manageable for you, because if you don't, you guys have a couple hurdles here. If you don't remember when we first came back in January, I tried to warn you that this first test, this first part, this first unit is the hardest part of this semester, and you guys have had the hurdle of it's been kind of broken up with snow and all that kind of stuff. Unfortunately, I can't do anything about that, so we're gonna have to make the best of it that we can. But with that review, I'm asking that you try get at least 5 questions done from that. So look at question 1. If it's one that sounds familiar to you, which it should, because I think that's Riemann sum, then that should probably be one of your 5. If you get to question 4 and it sounds like one we haven't done yet, or you just don't know how to do it, then don't count that as one of your 5, but try them in order. Try question 1 before question 2, before question 3. That way, as we get time, I can try to answer some of those questions for you and not stack them all up on review day alone. Okay, so getting right into it, one of the things that is going to start to come up a lot is sometimes we are going to need to know the difference between the distance traveled and the position of something. So we're going to talk about distance versus displacement and how we're going to handle that in calculus. All right, so displacement, all it cares about is how far total you are from the original spot. So just a real quick example, if you go 5 feet to the right and then you go 4 feet to the left, your displacement, the distance from where you started to where you ended, would just be 1 foot. So sometimes when we're talking about position, if we know where it started and we know how it changes over time, we know where it ends up. So for example, if we were at 4 feet and then it moved 2 feet to the right, we would know its new position is 6 feet. So displacement to me would be, and you're welcome to write this in your own words, but the distance from the starting location to the ending location. So most of you guys are probably going to go to sleep tonight where you went to sleep last night. So your displacement from the start of the day to the start of next day is probably close to 0. You're basically in the same spot. But if you went 5 feet to the right and then 4 feet to the left, you wouldn't say your total distance is 1 foot. Just like, again, if you woke up in bed this morning and tomorrow you wake up in the same bed, that doesn't mean that you traveled no distance today. You came all the way to school, you go to the grocery store, you go to Walmart, whatever, you go home, all of that adds to your distance. So you need the 5 feet to the right and the 4 feet to the left. All of that contributes to your total distance. Distance does not care about direction. If you're going left or right, it adds to your total distance. If you're going up or down, it counts to your total distance. So to me, well, I'm just going to steal this for displacement, and then distance would be something like all distance traveled regardless of direction adds to total distance. Now, those of you that are in physics or have had physics, I know this is a little more intuitive to you, but the big thing that is going to stick that we will need, and again, I'm not going to show you just yet, but we're going to talk about it just to finish off your notes. What math symbol is it that we can use that always returns a positive value? So the way we're going to deal with questions that ask us to find the total distance is we need absolute value, because we need it to whether it's going to the right, up, left, or down to add to the total. And typically if you're going left, it's negative. If you're going down, it's negative. So to make sure that stuff is counted towards the total distance, we'll need absolute value. So we'll see that here in just a few minutes. But any quick questions? Yes?
Do you need direction for displacement?
You need to know which direction things are heading, yes. But a lot of times with integration, that's kind of taken into account for us. But you'll see that on, well, we can actually look at, that's the next thing I was going to do anyway. Okay, so in your binder, this was 74. So let's quickly review what this area under the curve represents, what it has to do with calculus, and how we used it on this FRQ, because I think that partly answers your question. So last time we talked about looking at the units here. We could figure out that the area under the curve represented the change in velocity. So if we know what the starting velocity was, area above the x-axis increased the velocity. So area of 30 increased it by 30, area of 30 increased it by 30 more. But then if the acceleration starts going the other direction, that value starts to become negative, and then that's where the direction kind of comes into play here. So that's where it's counted into it. But you guys need to remember, as we move along here, until you feel more comfortable with integration, integration visually is area under the curve. This area under the curve is just a different way to do integration. Sometimes you have a function that you can do the antiderivative of. Sometimes you actually have to count up the area under the curve between it and the x-axis to calculate how stuff is changing. So I would like to look at this one. Again, we're just going to do 2 more of these. We'll save the last one for another time. But same thing, this packet was pretty big, so there is a scoring guide on there, but I think we can kind of relay this to what I just said on the last question. In the last question, this FRQ, I'm not going to keep sliding back and forth, but we knew a starting speed, and then based on area under curve / integration, we could calculate how the velocity changed. So in this question, we have a starting position at a certain time, and we have the velocity function. So instead of giving us a graph, we're given a function, but a lot of the same stuff. So we would like to know what is the position of the particle at when time is positive. Well, we know what the position is at time t equals 2. That starts off at 5. So just like that first FRQ, we took the speed 55 and then we added or subtracted based on how the thing changed. So we have a starting position. And then if we integrate, again, I'm not going to keep flipping back and forth because I think that's worse. But when we integrated acceleration, it gave us change in the unit below that. It gave us change in velocity. So if I integrate velocity, we need a dt here because our variable is t. If I integrate velocity, this represents the change in position. So this is how you guys really need to start structuring this in your head. In fact, this is what all the circuit is about that you'll be doing today. You've got a starting point, starting location, starting speed, just the initial whatever. And then this integration stuff, that's how it keeps up with the change and what's going on. Well, this this is a calculator question on this FRQ. So we can have our calculate integrate, but only if it is a definite integral. So I need to add some bounds here. So I want to know the change in value, change in position from what x value to what x value. If I want to know, oh, never mind. It says for any time. So I guess that would be it. Sometimes we need to put numbers there. Just for consistency here, I'll look up, and pretty sure this was just worth 1 point, but understanding this setup. Okay, they actually took a little bit different approach here, so I'm sorry. What I said is still true, so I don't know if I would erase this on your notes, but let's go ahead and tackle this slightly differently. If we integrate this, integrating velocity gives you position. You have to remember that relationship from last semester. If you don't remember it, you need to write it down and relearn it. Taking the derivative of position gives you velocity. Taking the derivative of velocity gives you acceleration. So now going vice versa. If you integrate acceleration, you get velocity. If you integrate velocity, you get position. So we can do the antiderivative here. Since we don't have bounds, we could put plus c. So this represents the position function. But how they want us to use this time is, we know the position is 5 when t is 2. So we're able to plug in 5 for y, 2 for t, solve for c, and then we can actually write out the position. T cubed minus t squared minus t plus c. Except now we know c is 3. I don't know why, but okay. That's fine. Just for consistency with my other class, I guess I glanced at this too much. We haven't done this one in the other class, so let's postpone finishing this one up. We can do this, but I want y'all to be on the same page as the other class. So let's go to this one, please. We'll just be a little bit ahead on that one. Okay, so a particle moves along the y-axis with this velocity. And we want to know, is the particle moving up or down at 1.5? So how does the velocity help us know that?
Velocity gives us direction.
Okay, so if we plug in 1.5 into the velocity, again, this is a calculator question, so you guys don't have to get out your calculator. I'll do the calculator part quickly. Calculator always needs to be in radian mode for calculus. We get that. So, is it moving up? Now this is, we've got a particle moving along the y-axis. So, it's like we've got, here's your particle. So it's either going up or down. So the fact that velocity is positive means that it is going up, and because at that time the velocity is positive. I give 1 point for that. Honestly, that's not anything different than what we did last semester. Velocity has direction, you have a calculator, it's not unique to second semester. Okay, part B. Find the acceleration at 1.5. Is the velocity increasing at that time? Why or why not? Okay, so how am I supposed to know acceleration at 1.5?
Velocity.
Okay, so this is the same thing as the derivative of velocity. And again, this is a calculator FRQ. Doing alpha window, your calculator can take a derivative with option number 3. So you could do this derivative by hand. This is one that we did last semester. It's product rule with some chain rule. It's possible to do, but you're going to have to plug in 1.5 into that anyway. So you're going to have to get your calculator out at some point, regardless. So might as well just do it now, but I'm going to cheat on that part just to buy y'all a little bit of time here. If I can find it. Okay. So this gives us about negative 2.048 or negative 2.049. On the AP exam, they do expect you to round the 3 decimal places, or you can truncate the 3 decimals. They take either one. And that was worth a point. Again, that's nothing new. Knowing that acceleration is the derivative of velocity and knowing that your calculator can do that. Again, if you guys don't remember that, I can't help you. You're going to have to go home and review that stuff. All of this is going to catch up with you now. Okay, but is the velocity of the particle increasing at this time?
Yep.
Okay, I would agree. And how do you know?
Because our acceleration is negative.
Acceleration at that time is negative. So it doesn't need to be any more complicated than that. One point for the answer and the reason. The answer was no. Acceleration at 1.5 is negative. Okay, now to part C. This is actually some new stuff, or new to this semester. Given that y of t represents the position of the particle, and you know when t is 0, it's at position 3, find y of 2. Well, this is where I was hesitating on the last FRQ because I knew this was supposed to come up and it wasn't coming up on that one. Think about how we did this one last time. We had a starting speed and then the area under the curve, or the integration, same thing, told us how that starting speed changed. That's how we need to frame this in our head. I've got a starting position of 3, and then integration, or area under a curve, same thing, tells me how that changes. Integrating velocity gives me the change in position. Now in the end, for this question, I want to know the position at what time? Okay, so what do you think my bounds, what should my end bound be?
2.
Okay, and my starting bound should be
0.
0. Now you've got to be careful here. This is right this time, but it's only because of this. I knew the position at time 0, and I want the position at time 2. So 0 to 2, this is the stuff that I care about where it changes. If this had been 1 at position 1, or when t is 1, if the position had been 3, I would just want to know how it changes from 1 to 2, not 0 to 2. Okay, but again, this is calculator FRQ. Your calculator can do this type of integration. Doing alpha window, option 4, you can type it in the way it looks. Don't need to try to do that by hand. This question gives a point for this setup. Actually, just for this part of it, they give you 1 point if you did the integration part right. 1 point if you do the integration part correctly, although they would have to be lenient there because this is a calculator part, and so your calculator could do that. And then 1 point if you get the answer. The answer comes out to be 3.826 or 3.827, depending on if you round or truncate. But again, your calculator does that, you just have to type it in. Once again, this is the thing I'm going to have you practice a lot on your circuit in a little bit. Starting position plus how it changes. Integration keeps up with how it changes. Okay, let's do one more part, and then I'll take a couple quick questions from this one. We'll look at one more. All right, find the total distance traveled from the particle from 0 to 2. So 0 to 2, integrating velocity tells you how the lower function changes. Integrating velocity tells you how position changes. But keep in mind that sometimes this particle is moving up, positive, sometimes it's moving down. So if I want total distance, what else do I need? Absolute value. And that's why we did that first set of notes. When this thing's going down, I still need it to contribute to the total distance. And thankfully, your AP exam always lets you have a calculator integrating absolute values. I'll show you how to do that in a little bit. Sometimes you can do that, but make sure you know where absolute value is in your calculator. It's also the first option if you do alpha window, which is where you get derivative and integration stuff. And if you look at the scoring guide, they also will count if you do it algebraically, but it is a nightmare to try to do algebraically. But they give 1 point if you have the limits of integration correct, 0 to 2. 1 point if you deal with the change in directions, so that would be the absolute values for us. And then 1 point if you come out with the correct answer, which again, that should be the easy part because this was a calculator question, 1.173 or 1.174. So parts A and B, if you don't remember those from last semester, spend 5 minutes tonight looking that back over because that stuff is going to come up a lot. Part C and D are what's new in this unit. Starting location, starting speed, whatever, plus integrating tells you how it changes. Total distance, make sure you integrate with absolute value so that it always adds whether it's going left, down, up, right, or up. Okay, any quick questions you see about that one that you want some clarification on, part C or D? Okay, then let's look at one more. We talked about the speeding up versus slowing down last time. Did we do that last time?
You what?
How velocity and acceleration are both positive, it's speeding up. If they're both negative, it's speeding up. Okay, it's just been a while. Okay, same thing here. So this is a calculator FRQ. I'll do the calculator parts for us. I'm more interested in us looking at big picture here. So this time we have a particle that moves along the x-axis, which means the particle is going, or object, whatever, it's either going left or right only. We've got an initial position, and they give us the velocity function. Sounds a lot like the last one. Part A, what is the acceleration? So how am I supposed to know acceleration if I know velocity? Derivative. So if I want to know the acceleration at 4, it's the same as the derivative of velocity at 4. Your calculator can do that. You just have to make sure that you know your calculator can do that and practice it occasionally so that you don't forget how to do that. Obviously not something I can help you with on the test. This comes out to be negative 0.523 or negative 0.524. 1 point. You could totally do that by hand, but why risk it? There's no value in doing that by hand just because you can. Calculator FRQs, let your calculator do 100% of what it can. Okay, part B. Consider the following two statements. When t is between 3 and 4.5, the velocity of the object is decreasing. Statement 2, during the same times, the speed of the object is increasing. Are either or both of these statements true or false? Give a reason why it is correct or not correct. Okay, so statement 1, the velocity is decreasing. Do you guys think that is true or false? One more time. Okay, and how did you know that?
The acceleration is negative at 2 is 4.
Sounds good. So 1 point, but you have to say true and give the reason. Okay, this is the part I want you to think about in your head for a second before we say it out loud, because it's not obvious for everybody. Statement 2, the speed of the object is increasing. Okay, what do you think about that? Well, wait, shouldn't this just automatically be false because acceleration is negative? Very good. That's what they, and I would say 9 times out of 10, that's what they're going to ask you on the AP exam. They're going to give you a negative acceleration and ask you if the speed is increasing or decreasing. It can increase to the right or increase to the left. If acceleration is negative and velocity is negative, so I would need to plug 4 into this, use my calculator, or actually that's just unit circle. Sine of 4 pi over 3 is something negative. These are both negative, so speed is increasing. It's technically increasing to the left, but you don't have to say that. For it to be speeding up, velocity and acceleration need the same sign, both positive or both negative. Okay, there was 2 points assigned for this one. I guess I would miss the first point because I didn't write down my answer, but true. And 1 point for the reasoning. Velocity and acceleration at that time are both negative. Again, we took notes on that just last class. I know it seemed like a while, but something else you might want to spend 30 seconds glancing over. Okay, part C. What is the total distance traveled by the object between 0 and 4? So, what type of calculus operation are we going to do if we want to figure out how much distance it's traveled? Okay, integrating velocity gives you change in position. That gives you the change in the lower function. I want to know between what time and what time? 0 and 4. Anything else? Absolute value. Great. Total distance. The problem with this as it stands is this helps you get location or displacement. When this thing's going left, it would be taking away from the distance as it stands. We have to do absolute value sign. But again, your calculator does that. You just have to know where absolute value sign is. It's in multiple places. Throw it in your calculator. We get 2.387. And for this question, they give 1 point if you got the 0 to 4 correct. 1 point if you dealt with the dealing of changing directions, which could be the absolute value signs. And 1 point for the answer, which my calculator just did for me. Now, of course, I know this is a small subset of FRQs, but these are fairly representative. This total distance asked is a pretty common question. And you can see occasionally you can even get 3 of the 9 points just from understanding that one part. There's not a whole lot to have to know there. Okay, finally, what is the position of the object at t equals 4? So what ideas do you guys have on how to figure out where it is at time 4? Okay, integrate what?
But don't use absolute value.
Okay, so integrating velocity will give me position. And what are my limits of integration here?
0.
Okay, so this tells me how it changes from time t equals 0 to t equals 4. Is that going to necessarily be where the position is? Because we also have to take into account where it started, right?
So 2 plus the
Right. Starting plus how it changes. Every time, phrase it in your head that way. I don't know why, but students forget the starting point. I know it gets kind of mixed in there, but they're giving that to you for some reason. Don't put absolute values this time. If it goes left, that changes where it lands. It would add to the total distance, but it doesn't add to his position. Okay, they give 1 point if you get the integral set up correctly, and then 1 point if you end up getting the correct answer. Again, this is a calculator FRQ, so you should be home free at that point. Just 2 plus, and then have your calculator do the rest. This is what our circuit is largely about today. It's called accumulation. How something starts plus integrate keeps up with how it changes. So, I know I'm going quickly here, but I don't want to go so quickly that y'all miss an opportunity to get quick clarification. So, part A was really a last semester thing. Part B, if you forgot about speeding up or slowing down, look at those notes from last class. Total distance, absolute value, and then this we're about to practice a lot. But is there something quick you guys would like to ask from this? And we'll have to come back and finish the other FRQ another day. My Abe Day class has not done that yet either. Okay, then let me double check, but I think we're to the, so I am going to ask you to turn in 76 before you leave today, so if you want to do that now, you can. But the thing I need you to practice today is these accumulation models. How something adds up or changes over time. So I think we had to do this in both FRQs we looked at this morning. So on this one, this has some calculators. This is how you know that you're welcome to just use a calculator. You don't have to do it by hand. You don't have to have some work and some steps shown. I assume you're going straight to your calculator. Okay, so if I want to know f of 4, we're going to look at just like 2 of these together here. We need to phrase these as starting speed, starting point, starting location, the starting something, plus, and then integrate keeps up with how it changes. So at this time, what is my starting value? It is 5. Starting value is 5. How it changes, we can do integration. If I integrate the derivative, it gives me the function. Integrating the derivative tells me how the function's changing. But I want to know when it's at 4. So that's going to be what to what? Everybody agree the n should be 4? Okay, I suspect a lot of people are going to think this. What's wrong with this though?
We don't know what it is at 0. We know what it is at 2.
Right, we don't really care what it's changing from 0 to 4. This is one downside of those 2 FRQs. They both were from 0 to something, but it's not always that way. I don't want to know how it's changing from 0 to 4. I want to know how it's changing from 2. I know the value at 2. I don't know the value at 0. I know the value at 2, and then I figure out how it's going to change from 2 to 4. again, on the calculator questions, I think for your study purpose, it's probably a good idea to write down what's going in your calculators, because otherwise you're going to look back at this and have no idea where this number came from. But you don't need to try to integrate that one by hand. Our focus is not on the integration today. It is on understanding how integration is being used. Okay, let's look at, let's do one more on the back. I don't know that, I'm not going to know the number, but you'll have it done when you get to it. So, the reason why we need to do a second one is, remember, integration, you can actually integrate a function, antiderive it, and that keeps up with how something changes. But sometimes you're not given a function where you can do the integration or you put it in your calculator. Sometimes integration represents area under a curve. So if we look at, I don't know, let's look at this one. To me, this is very, very similar to what we did on the first FRQ last class. This guy says when x is c, the value is 14. And then instead of giving us a function, it's giving us the area under the curve. But that's the same thing. So this 8 above the x-axis tells me it's increasing by 8. So at D, it would be up to 22. This 10 below the x-axis tells me it's decreasing by 10. So if it was at 22, now it's down to 12. So at K, the value is 12. This one's a little tricky. What do you think the value should be at B? Okay, it's easy to think 2, right? Because 2 plus 12 would give you 14. But this isn't plus 12. This is minus 12. Area below the x-axis is considered negative. So you have to ask yourself, what minus 12 gives you 14? And that would be 26. And then finally, at A, what would this value be? 24, because 24 increased by 2 to gives you 26. Now I know the values of all of these, and this particular one just wants to know the minimum. So smallest value look to be 12. But again, sometimes you have a literal function that you can integrate, like question 1. Sometimes integration comes across as area under the curve. Sometimes the area under the curve is given to you, like this question, and sometimes the area under the curve, like this one, you can seek it out. If you need to know this area, it's a triangle. 1/2 base times height. You can calculate the area yourself sometimes, if it's simple geometric shapes. Okay, so this is the type of reasoning and questions I need you guys to master for me today. So go back to that question 1. Did that match up with one of the answers? Right below it? Okay. So again, if it's got a calculator there, feel free to just throw your stuff to get your answer in the calculator. The rest you need to make sure that you know how to piece together. So I'm going to give you a few minutes to start that off before I start coming around. Ideally, you guys finish that up and turn it in so you don't have to worry about that for homework. But I don't know, this clicks quicker for some people than it does others. But seeing how you can use the calculator, honestly, these questions don't take too long once you know what you need to do for each question. I'm going to finish grading this homework real quick, and then I'll come around and help you wherever you're getting stuck. course, you guys know I always recommend that you mark the questions that you initially miss or initially need a hint on, but I think it's probably a little bit more important than normal with how disjointed this semester has started off. So consider that as you go through these questions. Feel free to work with your neighbors. Feel free to call me over in just a minute and let me help you as well, but probably a good idea to look back at that question.
Everything for this one?
Okay, anybody still stuck on number 2? Can I come around and help?
They're plugged in 1 or 2 over 16.
And this is the rate that's going to be done, which how much is in there.
Okay, what you're doing is fine here, but right here, you don't need to integrate it. Your calculator's gonna do the integration.
Yeah.
Yeah, that's
So
just
that's
gonna
the
stay the same. Because integrating velocity, you're gonna get your calculator.
So then you need to integrate that.
If it was a non-calculated question, to go from what you're about to put in the calculator to your answer you have.
You're starting.
Anybody else need a hand with number 2? Okay, what about number 3? Anybody tried 3 and stuck on 3?
Yeah, what do you want to do? Just, yeah.
One or
For example, so I was in because you're finding that I just put it in and I'm not it's not an option.
Hold on, one second. If you were to find and then you like separate it into different parts, like plugging it in, so you plug in this part and you plug in this part, and then you just subtract it.
It could be either way. But just kind of glancing at something there.
Let's try this.
You want to know the area under the curve of 1 and 3. So find the area of this triangle, and then add the area.
No, this one's how you need it.
Like this.
Yes, values too.
Except that the area on page 2 you have to find which ones.
So are you guys going like in order again?
No.
Or how do you drop
That
that?
didn't go long. We didn't do great. That maybe not. Do we need to integrate?
You do. Why don't you have integration on your paper though?
Why do we need
Looks like you did it right.
You have the rate that oil's being pumped in.
Yeah.
And in the end, I know how many.
Oh, that doesn't work.
I guess why is this? Is that like?
Okay, what's your starting value? Plus, now the changes is gonna be the integration.
So we can't just do this. We just plugged it
Oh,
in
wait.
too. What is that? That's how fast. It's being.
Oh, yeah, it's in.
Okay, so you plug in what for that, 10? 102?
102.
So when you plug that into this, you are adding the rate at exactly 102 seconds. Yeah. You're not adding up the rate at 0 and 1 and 2 and everything in between. You can't physically add up all those in betweens, which is why you have to. Also, that's per minute, so make sure you change that 102 to 1.7, because I got it. And based on the wording, no oil is being removed. Means you need to add something else to your thing before you go to the calculator. Nothing is being. Okay, stuck on number 2 or number 3?
I'm so sorry. No oil is being removed.
Okay, stuck on 2, 3, or 4? Okay. Keep going. So you guys know that I like these circuits. I think that they do a good job of giving you some variety, but this one in particular does a great job. As you guys work through these, you're going to see there's like 2 questions that sound almost the same, and they make one tiny little change, and it changes how you approach the question. Just looking at the back, you can see the top 2 look similar. 2 in the bottom right look similar. 1 on the right, 1 on the left look similar. 2 of the word questions on the front are pretty similar. So again, just a couple word changes where you need.
Is it 1.70? Yeah. Okay. Comes up to No, I'm saying I think we're supposed to have so that You got it for 5? Oh, yeah. You did?
Okay, if you're stuck on any of the first 6, call me over, please.
That's what we got first.
I got it.
Did you integrate?
Okay.
So what's your starting value? Okay, so 30 plus. And then how does it change? Okay, and what are you going to do?
Right? Did you just have
Okay. So all that sounds good.
But-
Do that in the calculator.
Wait, I had 5. Did you do it?
Yeah.
How do we get different numbers then?
I don't think the absolute value matters here because I don't think that
Where
rate
it goes
is.
down. Oh, I plugged in 1.7.
What is rate percent?
Are we supposed to do that?
No, so.
Well, that's the balance. Okay. It's not doing.
Yeah, the rate is measured in what? Gallons per minute, but then they
It
give
works
you
now?
102.
So do I guess that makes sense?
No. You have to find the answer right there. You're not integrating from 0 to 102. You should be integrating from 0 to 1.7. You need to change that to minutes.
Yeah, I got it.
Oh, no, it's not.
Okay, anybody else that can come help?
Yeah.
First 4 and 5. Okay, so what's your starting value? Okay, plus. Integration can tell you how it changes. So you know the value of 2, so you're starting at 2. You want to know the value. Okay, so you're going from 2 to 0. That seems weird, but you can do that. Just go right to left. You just can't make that value change back. That's a calculator question. That's not going to matter if you have a trig function, but everything in calculus. If your calculator is in degrees, you're going to get some unrecognizable numbers, and your logic might be okay. Comparing it to this, we knew a value at a certain time. I know that the value at 1 is 3. So I just put
My best guess, I would say.
and then you want to know the value at 2. So you're going to have to calculate the area from 1 to 2. Because you've got to find the area that will rectangle.
It's gonna be 3 plus something, right?
From 1 to 2. Instead of using the whole area here, you're actually having to find the area. And then you have
What's
to remember
the
this thing.
I guess it's,
Well, the area there is.
it's the area under the curve.
Want to help with
If you switch that, that looks good.
And the area.
You need a plus sign there. I don't know if you put a plus in your calculator, but
You're saying the area is.
it's gonna be starting value plus,
Yeah.
yeah, and then the integration. Yep.
Yes, so it's just weird, it doesn't.
So you're adding this.
So f of 3, you're trying to figure out the answer when x is 3. So if you put a 3 up here, this is just a fancy way of saying find the
Yeah,
area
we're on
from
it
1
right
to
now.
3.
We're thinking.
So
3
find the
minus
area, there's
3.
2
Like,
triangles.
why is
and
it the
add
end of the curve?
Yeah.
Well, we know you start with the 3, right? 3 plus something. But it doesn't connect, so we're confused. Mr. Johnson? So we know this starts at 3, so 3 plus, and then we're trying to find from 1 to 2.
So that's a change of 1 to 2, right?
Right.
So same thing as up here,
Yeah.
no value, and then area under a curve told us how it was changing. It just said up here, the areas were told to you, down here, you need to actually find the area yourself.
So we can just, but it doesn't connect, is that weird or not?
It's still the same area, from 1
Okay,
to 2.
so it's still gonna be negative question down here.
Yes, just draw a
Alright,
little
so,
rectangle.
Okay.
And it's
maximum
negative
of
8, so the x-axis.
function is always that one.
So area under a curve slash integration, same thing, tells you how it
Find all
changes.
those critical numbers.
3%, so 0?
B, C, D, and K.
They're not that difficult, but you like, you have to like really focus on those.
And one of those is maybe maximum.
What about
One of those can be
starting
small.
value?
Okay.
How do I know that?
Makes sense.
And
Yeah.
so you need to
I
know
guess-
how it changes from 1 to 2
We make it make sense. Yeah.
Okay, you don't have a function that integrates,
See at it.
but just like this one up here, this area under the curve is the same as integrating, and it tells you how it changes.
And he's at 0.
Have zero, that's right. Okay. Right, so you have to draw that little rectangle from 1 to 3. Or 1 to 2, sorry. And then the area of 93.
What about
So the area under the curve means from the function to the x-axis.
Well, it says
Just add
one.
below.
I guess because that's the derivative, so it doesn't have to.
It's the same as the other one.
Yeah.
Yeah, to me, it's the same as, it's really the same as this, it just seems different, but you had a starting value, area told you how to change it. You get a starting value, you're calculating area to see how it changes. So sometimes the area is given to you, sometimes you have to find it with
I don't understand how like
the function from here to the x-axis. This is the area under the curve. So it is from
What about, like, the f of
here,
Oh.
but the function is on that big.
I believe this is because it's the derivative. It's not the function, right?
Now, you need the graph to be the derivative, so that its area represents the change in the function. Which is what
I
you're
thought
trying
one of those things isn't showing the graph because it's.
Oh, yes, yes.
Okay.
F1 is referring to the function, which is not, there's not a visual for it.
Okay, so,
And then the visual is up here.
Okay.
It's the same as this, it's just, like right here, see the function.
No, you gotta solve for
They
every
care about
single one of those
the other
points.
stuff. And it's
So
the
you gotta
function
solve
to the
P,
x-axis.
which you just did, 22. And you gotta solve for K.
Oh, okay, so after that's.
Okay, anybody stuck on the first 6 or 7?
Which is 14 from 18.
What's the difference?
Nope, it's
13 and.
go and label those.
Well,
D
13
changes,
is
don't
not
have
that.
that back.
Yeah, that's
Then you
okay.
find this area, so it's like negative.
So K is D,
32. That's all you do, right?
but that's,
Yeah,
that's
subdivision on.
under the x-axis. So it's 22 minus.
It's just weird they didn't label that.
But remember, you're moving, backwards here. So even though it's negative
So you
under
need to
the
choose that.
you're actually adding.
Oh, yeah.
Divide that by 16 to get 1.7.
Yeah, that's weird.
It is. But now you just pick the biggest number of those, and that's your maximum.
Yeah.
Okay. I think I get it then.
It's 4.4 and answer. Oh, it is. Sweet.
Zero, 1.7 minutes. Very good. I'm afraid you're gonna forget the part, that's why I think that's that first. You're gonna set, you know where it started, the integration keeps up with how it changed over time.
Well, yeah.
Like, why is it starting here? Based on this, it says you can start at 1. So over here, then you start at 1.
Or 1 plus 5.
Wait, do you think this has an area of 1? And then this has an area of 1? Those aren't the same size. From 1 to 2 has an area of 1, and then from 2 to 3 has an area of 1. So your final answer ends up being 6. Yeah, but you were trying to find the area from 1 to 3 in this question. And I know from 1 to this is there. This question, you're trying to find the area from 1 to -2. That's making you try to think about if you're going not left to right, but right to left. I'll come back. Yeah.
What is solve the area?
Well, for that one, you needed,
That's the area I moved.
okay. So, area of 1 is -2, so you did that. Okay, so what shape is that?
Yep. Oh, yeah. We're gonna start with
How much of a circle?
Pi r squared.
So do pi r squared divided by 4.
So we'll go. I'll do subtract everything, right?
Okay.
So then you would
This one you actually have to do quite a bit by hand. If you have acceleration, you could do the antiderivative to get velocity, but you would have a plus c.
Is it negative?
But then they give you this so you can solve for c. And then you have the velocity function, so you can integrate it the second time to get to accelerate position. You're going to have another plus c, but then because it's in there, you can solve for that plus c. And then you've got the real position equation, and you can plug in 6.
So there's over the x-axis, like, even on this one, if we're at 22, and then there's over. Oh yeah, -1 minus 2. Because you're subtracting this. You start here. Positive, yeah. But this is 0. This is 0.
Yeah.
So.
Since you started with 1, so 0.
Yeah, yeah. And you're adding 1. You know what I'm saying?
Yeah.
So we're trying to find like what it is. So you're adding 3. You're adding pi. You're adding 1. You get here. So this is negative.
You guys still have about 25 minutes of class, but I know some of you are close to finish with the circuit.
Basically, this is like.
Don't forget, I am going to ask you to turn the circuit in, so if you're
and since this is above,
working well,
you're adding 1 to get to 0.
you might want to turn
This
this
is like
in.
negative 1. I don't know. Maybe that's what you're
So it's like 3 which is 4, and then we divide that. Okay.
So, like over here, you're going from left to right. So, just like on a number line, left to right you add as you go on. But if you're going from right to left, the area is still the same, but you just make it all negative. You just subtract it. Opposite directions of the whole thing.
Okay, so. It's very simple,
We haven't talked about that one yet. It's similar to, did you figure out the difference between these
Can I go to
two? Yeah, so if you're going left to right, just like on a number line, you add. But if you go right to left, you just make it negative because you're subtracting it. So integrating from 1 to 3 is the same thing as the negative of integrating from 3 to 1. So these two. Yes, they switched the balance and they made it. So these two are the same. Yep, those two are also the same. Also be the same. They'll all look true. No, yeah. Sorry, I think it's these two then. So there's 2 inches. Yeah, that's kind of awkward. But yes. We haven't talked about that in class yet. We don't have to worry about it yet. We'll do that. Hopefully by the end of the week. Also, this is a B week, so I know we're a bit behind A-Day stuff, but I will see you guys 3 times this week, so that will get you caught back up. So like every week, how to report it was supposed to be creative. Anyway, I'll show you.
So that's the sense.
You guys are just using the same problem.
Yeah, it is, but sometimes the minimum is
Okay, so if we compare these two, this one ultimately is one of the areas from 1 to 3, right? So just like on the number line, if you're going from left to right, you add. On this question, you're going from 1 to -2. So if you're going the other direction, if you're going left, it's the same amount of area, but you need to make all negative with your subtraction. So that makes it negative. It's all the areas going the other direction. Okay, but what, let's look at a question we were working on, Jillian left this. So that should be the last one. So they give you the acceleration, this one you have to do a lot of. They give you acceleration. What can you do to that to get velocity? Antiderivative, yes. Okay, so antiderivative. Okay, plus C. There could be a constant, so plus C. But then, notice they give you a value. B of 0 equals 4, so that allows you to solve for C.
Yeah.
So the real velocity function, since you had that point, is p squared plus 4. Okay, what can you do to velocity to get the position? So just do it again, basically. Integrate it again, you get a new plus c, but they give you a new point. Well, opposite just means what? The antiderivative? I would say raise the power by 1, divide by the new power.
So basically, you start at 3, right? And then you have a -3 down here, that's 0, and then up here is 1 and 5. So 3 minus 3 is 0, and then just 5 plus 1.
Raise the power by 1, divide by the new power, and check
I
by
did
taking
this.
the derivative.
I did the
I
triangle.
bring the
I
power
got
down,
1,
and
and
then the power
I
by
did
1 does it give you 2 squared?
quarter circle, and got
That's how you
5.
do it.
No, 5 minus.
Okay. So plug that in for C, and then you have the real position equation.
I'm just so bitter.
And then you would
I mean, I already
get
went through it.
6. So they're making the numbers easy to work with, but it's like the whole process. Integrate acceleration, you get velocity, solve for distance. Integrate velocity, you get position, solve for distance. Then you can find any position you want to go.
Alright, so this is Scott. This is decided with mail, correct? Ignore the tentacles.
Sure.
Don't worry about it. But that's definitely mail face, right?
Sure.
Well, I started and now he's a lesbian?
I was thinking Eldritch, but okay.
Well, this one says how many meters of the third.
Oh.
So that, no matter which direction you're going, you want it to add its distance. This one uses absolute value of something. Whereas this one says how far away is it from where it started. So you should not have. So it's basically it's a displacement versus a distance.
Look at this.
Anything I can help with? Yeah.
And I love it.
So,
You're trying to find the area from what to what. Okay. So this is going to be a rectangle. From 1 to 2, it's just going to be that. 3, but it's below the x-axis and negative.
Then what did I do?
Well, that is just like the same way we used to. We had a value, the area tells us how it changes. Down here you have a value of 3, the area tells you how it changes. So your final answer would be.
I think I was just so
It's really the same thing. It's just that sometimes you're given the area, sometimes you don't find the area. But very similar.
He's an anti-mask. Yeah.
I thought they were just different images, that is cool.
But really, he's a lesbian. It's mostly lips, but it's also the eyes.
Yeah. I just kind of lost shadow there.
Yeah.
It's a glowing eye.
Well, no, this one has a bit of
It is really cool. I had no clue that you could do that before. Those are. Yeah, we can look at it.
No, I've got some great stuff in here.
Those are really good.
Yeah. I did this whole the night before Christmas. The night before gift exchange.
The night before? You did not get sleep, did you?
Actually, I got plenty of sleep. But I did the night before and the day after. It was very rushed, and this person does not look like the person that she was supposed to look like, but he looks great. And I put it up as my contribution to a gift exchange. And you know what I got in return? Potatoes. This is my stepsister's, and I'm going to them for lunch.
I know, I can
This is
Your
the
acceleration.
portfolio and these. I did this in this class. No, I did this in advisory, but I have one in my old
And under
binder.
this, you got fat.
Yes.
Under there, they give you a value.
I sold this one for $1. It was my first ever on sale. This is the one that's in my calculus binder.
That is still really cool.
Yeah,
So that means
it
up
was my,
here, so real
these are
velocity
my test
function.
works.
So you have one
My LEDs.
unity squared plus this.
And I wasn't sure what to draw, so I just put
How do
the
you get
one.
from velocity to
I don't know which you're in, normal or.
If he like,
Yeah, that's my teacher made us.
Your headers, I have a ribbon in here, so.
that would have been really cool. We had a very boring English teacher.
This is more than 5 pennies.
Slightly more, yeah.
So C is
They're
negative.
really cool. I don't know what Werewolf is though.
I got C was 5. That's why I thought. So then they give you this information. Position is
Blanket?
This is the first
5.
assignment we had for our
This is how you got lucky.
an Elementor and Prince Boulevard.
Really, this is plus 2.
What? Oh.
Okay.
And we had to,
You started at this too.
You're probably chances were
And then we had to draw another.
that's 0.
Is that Jeff's?
Yes, and then we had to draw another picture, but with modification, which I used color pencils that time. And then we had to apply a constraint. My constraint that I chose was I worked on two chapters, so now it's one circle.
Dang.
For our class.
Nobody.
That must have been difficult too.
Not really.
That's genius.
Really?
Best book that I've ever drawn.
I didn't see it.
Don't
Very
think we
good.
ever saw it. I quoted it on the summer and I never did. For like a
There's a
solid week or
chance.
two, it was in the top 10.
Oh, dang.
But
Can you?
Yeah.
Can you go? Or no?
Just need to turn it in.
Yes.
Not yet.
Okay, I just wanted to know.
Okay, you need to do at least 5 questions from your review. Start with question 1 before you go to question 2. I mean, if I was you, I would do more than that, but I think 5 is at least something, moving you in the right direction.
0 to 6.
Yes.
Okay. Where were your reviews?
At the second result, it was not that to expect only half 50% shorter.
What about like putting 8?
Google would have probably this was.
And then
Those
that'd
are
be it, right?
very random.
Yeah, see if that works.
Would you? Yeah. Yeah. Something that we need,
Oh, no. The height
Yeah,
is
yeah.
switched, so it didn't help the last year.
Still very, yeah, very impressive.
Candy careful.
you need,
Jeez, cult member.
And makes it even more sacrifice them.
Let's go with my takeover
I agree.
I guess.
Listen,
It's like, that's the answer.
and guys just looking adorable.
Oh. Let's try this. Let's try 8. Well, let's
The last year's one that corner was this.
Which one?
This one.
That's like the best one for us.
I know.
The only thing that is the opposite is the nose, and that's it.
Yeah, the nose is really awesome.
Why do they say it's a calculated problem?
But it's like, it's still really good.
Is it?
Yeah.
Okay, so
Yeah, but
also
I mean, they were tiny in actual impact. Also, it's just not, it just doesn't work so fast.
I know. Kitty.
Yeah, I remember that. It was so,
Yeah, I forgot you mentioned
yeah, that was like,
I feel like this is a really complex
smell
question.
of the brain, it was like, what was it?
Yeah.
But to me, that's a lot of like what you just did.
Yeah, it was like, the word for smell of brain. What is it? Maybe, there's something.
Equals 4?
Basically, integration. So they want you to come up
I'm
with
thinking of a different word.
One is why there's a whole class after you do calculus 3, the next class is called differential. And that's like, you only look at the application. Try to find the original why function. Because the Wi-Fi, I'm thinking is good.
It's just your different words. I mean, this is more to like half a way.
So you do actually use your question? Are you ready? Zero's on top, right? Yeah. Because No.
So there's one more thing to this one. So the area that you found, that's correct.
Wait, how do you see macadamia?
Remember, so the
This one
starting
you were
point
going
is
1
3,
to 3.
one F is
So the
1.
second one
Okay,
was
so
the
you're
left to right.
starting
I haven't seen anything yet, okay? I'm sorry.
Just don't watch it.
I don't watch it.
It's not TV.
I don't watch YouTube either.
Ah.
And then the area
I watch later.
of
The
the
playlist is like 30 videos right now, and it's all just things that have popped up in my subscription.
It's so good though.
the area of the
Like,
I believe you,
They
trust me, I
raised
do.
$2 million
No
from
spoiler.
No, like they raised the charity to be able to fund the show, and they
Have
raised
you
the
seen,
most
um,
ever for a TV show.
Have you seen
Like
Epic
Ritchie
Race?
Brothers. No, I remember you recommended that. I've not gotten around to it.
See? Typical.
Yeah, but that's an entire show. This is just a pilot.
Have you even seen the pilot of Epic Better Race though? It's like
There's a
20
pilot?
minutes. It's not, it's a TV show. The pilot is just the first video.
Yeah,
Or
I mean,
episode, usually.
yeah. Normally there's something different. Like the Owl House had a completely different pilot than the actual show. Did you watch the Owl House?
No.
Mm.
I'm just saying, thinking of like other shows that had pilots that were pretty good.
Yeah.
Yeah, I mean, I can't.
Like the Hello Boss just doesn't even consider the pilot to be canon anymore.
Okay, I do need to interrupt y'all here for just about 2 minutes, real quick. You guys should be doing CAP when you go. There's no movement this week in advisory due to CAP. And specifically today, you're supposed to learn the process. And I think you're supposed to start picking out your math and English class today. So I put in recommendations. And of course, you need to pick what's best for you. But most of you guys should be going to Cal BC. So of course, if you're a senior, in college, you should either be taking Cal 1 or Cal 2, depending on if you take the AP exam, but your university will help place you. You guys, if you are not a senior, should probably take Cal BC next year. If you are thinking about not taking Cal BC, if you think AB is too hard or too much work, please, please, please do yourself a favor. Find somebody that you know that's taken BC. BC is a much slower paced class. They can go at like half the speed that AB has to go to. In fact, the numbers kind of give you an indication of what you learn in BC. Cal AB, you learn the A unit and the B unit, and then in BC, you review the B unit and you do one more new unit, the C unit. So there's a lot less new material in BC than there is in AB. Also, just to compare it to the university, pretty much what we did first semester is what a Cal 1 class is like. And then what we have to accomplish second semester, this is actually about half of Cal 2. So, again, BC is a lot slower paced, a lot more time to absorb the information. The BC exam tests on a lot of the AB stuff. So before you don't sign up for BC, just make sure that you're well aware of all of that stuff. I would hate for you to make a wrong decision. Of course, you're welcome to ask me specifics if you have specifics, but we've got about 2 minutes. Make sure you turn in 77 before I see you on Thursday and work at least 5 of the test review questions. The more you do, the better.